So this is the third milestone for the ParticleKnight game. So we know from the last two checks of milestone, we got the player that is moving, as well as an attack animation, running animation. We've got impacts of damage from the enemies. Same thing with the enemies attacking. Cameras also following the player. And collisions, rigid body, everything is working as well. As well as the enemies on death. There's a little more explanation for the enemies. Such as you can see, the enemies are moving throughout the level and they're aiming at the player and attacking him. This is all thanks to a specific element that I'm using for the enemies, which is the special nav mesh component. And for that, I have a different type of game object in the editor where I have the AI scripts being read so that the enemies are able to navigate throughout the mesh. The way this works is we're laying down a mesh for the AI. And as I click through the bake, what it does is that it's a specific script that it finds all the layers defined, including the ones that I was including, which is the ground layers. And it can also include all different kinds of layers as well. But for this case, I only have the ground, since this is the only ground that we have. There's also the specific layers that we can say as well, such as water, UI, and player. With this, the AI navigates around the level, and there's also a script with every single enemy that I have, which I'll go to prefats for this. The enemy has already drawn components here. These spheres come from the enemy AI scripts that I have defined. In this shows these are the gizmos that are drawn automatically within the script. Yellow defines the AI being in range of the player, which has a state that will initiate the AI to chase after the player. Once the player comes into range of the red sphere, the enemy AI will start attacking, stop moving, and will start attacking at the player. And that is essentially what the enemy AI script does. We place the nav mesh agent. Then we have the transforms of the player and the attacking point for the specified AI, for the specified enemy object. Then there are masks that we're placing as well, aside from the tags of the ground and the player. We have the enemy health. Then we have set up the vector 3 walk points set, and then the range This is for the patrolling, necessary for the patrolling state of the module of the script. Then we have time between attacks, turn point, how fast the enemy object is able to turn to face the player. Boolean of already attacked the player. Then we also have the projectile that the enemy object is using to shoot at the player. Then there are the following states: sleight of the attack range and sight range. These floats are important because that is what defines the gizmos that are within the scripts. They're basically defined to indicate how big of a range the spheres have. And this can also be done in the case of if the object is flying above or is below the player. On the awake, we're trying to make sure we find the transform of the player, and we're also utilizing the navigation mesh. In the updates, it is checking for the range of both the sight and attacks at the same time. If none of these are true, then the AI will perform a patrolling state. If there is not a walking point set in which it will always calculate and search, it will always initiate the search for a walking point. And this walking point, it's randomized based on the walking point range that you want it to take. These inputs are then placed, and this is the new walking point. With this, we set this to true, and once that does, and then once it repeats, it sets the destination for the AI. Then the set destination. Set the destination. Then it will perform the walking sequence to that specified point. That is the whole defined description of the patrolling module. But if we're somehow within the range, if the AI is within the range, if the player is in range of the AI sight, but it's not in attacking range, then it will perform the chase player module. Chase player module, all it does is that it sets the destination for the agent for the enemy object to utilize to travel to that point. It will always utilize this until the player gets off of the player in sight of the enemy AI. And if all of these are true, then the attacking player module is called. It will stay, the direction will always turn to face the player position in the transform position. Then we're making sure that the set destination is set to itself. This way makes it so that the enemy object stays in place and continues to shoot. The direction y equals 0, this is to prevent it so that the enemy AI does not aim while you're hovering up. But if the designer does not want that to happen, they can comment out this part of the coding line, and with this off, it will always aim towards the player no matter how far high or low they are. In addition, they will also rotate to face the enemy player as well. Then, if it did not attack already, then it does this performing coding line. What this does is it instantiates a new projectile and fires it at the player. And it always resets here to already attacked. And then it will repeat the sequence as after already performing this, it resets the attack as if it did not attack. Then it always aims again and then it attacks again. This will continue until the player gets off of the range of the attack range. Go back to chase the player if it's not in its attack range. Once the player manages to escape both the inside attack range and once the player manages to get off of the inside range and the attack range, the AI will go back to its patrolling. We also have a public void take damage defined module to make sure that when the time comes for the enemy object to take damage, we can call it from a different script and then specify the amount of damage we want to do. It will lose that damage to the health. Once it goes to 0, we invoke the destroy enemy. In this destroy enemy, for another module, for the next milestone, this is set up for the next milestone, which is to update the score for the UI. And the last step would be to destroy the object. The on-draw gizmos, what it does is it draws a red line for the attack range, and the sight is defined for color yellow for the sight range. That is what we have defined within the editor, which is why we see these spheres within the object itself. The spawning over time, it's another review from the last milestone. We generate new enemies here. In this script, generate enemies, we have the object of the enemy within the script. We have we have integers position set to public so that the editor is able to, so that the designer is able to set the integers they want for the position of the spawning points. We're taking only the X and Z positions, as the Y is for how high or how low that object is. We also have the count of how many they have spawned so far and how high that count can go. It starts a coroutine, and then we emirate it, and it will spawn until we reach a high point. Then it counts down, waits for 5 seconds, and then we count down. It's done so in this way, so that way the game does not last for an eternity. And I also have a script defined within the UI code that says once you reach to 20 points, the player will instantly win. That is something that I've set up for the next milestone. I can show that real quick here within the script files. We have a score tracker. And with the score tracker here, we have a text of kill counter, which is one of the in the UI. There's an int defining what number of kills the player has. And it'll always update within the UI to string. As well as for the game out, the last thing for the new mechanic, which is set up for the next milestone, would be the game outcome. This is the script written to determine if the player wins or loses. The set score is set to greater than or equal to the kill count, or 20. If the kill count is greater than or equal to 20. In this update, we're trying to find the game object of the score text. We're getting the component of the score tracker, kill count, which is going to be the integer from the script itself. If it's greater than or equal to 20, we will activate the screen to win. Time scale is set to 0 so that nothing moves once we win. Message is displayed, and just like in the previous script of pause menu, we're going to deactivate these 4 things from the player. The character controller player movement, the projectile, which is to fire the projectiles for the player, as well as the camera controller. Then we lock the cursor lock mode. We set that to none. These are the conditions for the win. Then for the lose, as seen in the previous milestone, if the health of the player is equal to or less than 0, then the lose screen will be active, and again time will freeze. These 4 things, components from the player as well as the camera, will be deactivated. Cursor lock will be set to none. And the purpose why that is done is so that the player is able to click on the buttons when the UI is prompt. Final demonstration for how the nav mesh works. I'm going to find the game object of nav mesh and this set layers that I have already placed within the level. As we play the level, the enemy objects will be spawned at the specified randomized integers of the one specified for the X, which is 50, and the Z, which is 31. You need to make sure to take the maximum range possible from the level itself, so that way the enemy objects don't spawn out of range for them. And that is everything that there is to say. And that's all the updates that I have to find for Milestone 3.